Okay, welcome everybody. We are looking at vectors again today. So one of the goals for today is for us to work with a couple of vector operations and then put them into practice. So one of the vector operations we're looking at is how to make a unit vector, and the other one will be working with the dot product. The dot product being very important, or probably one of the most important operations with vectors. Then we're going to have a go at applying some problems in real world and solving those. So, first up, unit vectors. So a unit vector is a vector with magnitude 1. So if you imagine any vector, a vector is going to look something like this. You've got some sort of a line with a direction in it, and it's going to have a magnitude. So the magnitude of the vector is v. What we do with a unit vector, it gives you a single unit of that vector, is you resize the length of the vector so that the magnitude of the vector is equal to 1, but the vector still lies in the same direction as the original vector. So this is a skill that we're going to practice to begin with. You can use it later in problem-solving questions. It becomes useful to have something that goes in a particular direction but doesn't change the length. So in order to find a unit vector, we have a vector here, the vector 3, 5. First thing we need to do is to find the magnitude of this vector. So the magnitude of the vector 3, 5 is going to be given by the square root of 3 squared plus 5 squared, which is root 25, which is going to be 5. So the magnitude of this vector, oh no, it's not. What am I doing? Craziness. Okay. I thought that was a 3, 4, 5 triangle, but it should be 4, but no, it's not going to be. All right. I have to actually work it out. Sorry. It's cheating. This is going to be root 9 plus root 25. Why wasn't the vector 3, 4? That would have been much more fun. That's going to give us root 34. Now 34, we can't simplify that. Isn't that 2 times 17? Yeah? So we're not going to be able to simplify it further than that. So if we wish to have a unit vector of v, it would equal 1 over root 34, 3, 5. We could write it like this. I did. I said 34, my hand wrote 35. Weird. So we could write it like this, and probably this is the best way to leave it. If you want it as a decimal expansion, you could. I'm not going to do that right now. But you could also write it like this. As the exact value. Okay, so next up we are going to look at something called the dot product. Now with vectors and matrices, in fact, with vectors and matrices, when you multiply by two components together, the result is different depending on which type of multiplication you use. So for instance, what I'm talking about is, what is 3 times 5? 15. What is 3 times 5? Now, in vectors, these are not the same. We have 2 types of multiplication, and in arithmetic, as here, and in algebra, they produce the same result. In vector and matrices, they will not produce the same result. Multiplication works differently in these number systems, which are more complex, and they'll give you different results. John?
So it's because of the difference in the dots or the times?
The difference in, so what we have here is dot multiplication and cross multiplication.
What is the dot called? It's just called
dot. Dot. In vectors, so in vectors we do have different names for them. So if we have the vector v times the vector u, and we have the vector v times the vector, times the vector u. This one is going to give us a third vector, w. This one is going to give us a number, a scalar. So when we do cross multiplication, the result will be a vector. When we do dot multiplication, the result will be just a single number, a scalar. This is why the dot multiplication is also called scalar product or scalar multiplication. Product being a better word than multiplication. So the dot product or the scalar product, it's quite easy. So you multiply this number by this number, we multiply this number by this number, and then we add them. If we had a third number, such as U3, V3, then we just do U3, V3, like this, just extending it like that, dot, dot, dot. So this is the arithmetical approach to solving, finding the dot product. Now, what's interesting is we also have a geometrical interpretation of this. So u times v can also be interpreted as being the length of u times the length of v multiplied by the angle between the two vectors. Now, any two vectors are always going to cross. Is this true? Discuss with the person next to you. Will two vectors always cross? Okay, can we hear from the class? What do you think? Will two vectors always cross? Yusuf, why?
Because sometimes they can be parallel.
Perfect. Sometimes they could be parallel. So they will, all non-parallel vectors will cross.
No.
Yes, because, for instance, if I draw the red one here and the blue one there, then they're not crossing, are they? But vectors have no location in space, so you can relocate them on top of each other, so they do cross.
But they have magnitudes. What if they're like magnitude? Because they're not a line. They don't go on infinitely. Yeah.
That's true.
So if you just put them far away from each other, they won't cross.
Then move it.
But you are you just allowed to do that?
Yeah. You just do this. Now it crosses.
Wait, with that logic, sorry. With that logic, if they're parallel, then they'll also cross because you could just move them on top of each other. What's the difference?
They're not crossing if they're collinear.
Oh, right, yeah, that makes sense.
Yeah. But good questions. Good questions. Okay, so the result is a scalar of the two vectors, but we can use it also to find the angle between them. So let's have a go at using this formula a little bit. So remember the formulas? We multiply the components and then sum them, or the magnitude of each times the cosine of the angle between them. So here's an example for us to get started with this. We have the vector u and we have the vector v. Find the angle between the two vectors. I'll give you a couple of minutes to have a go at this yourself. I shall come round and make snarky comments to each of you who's not working hard enough. Let's have a look. So what we need to do is we need to find the dot product. So u dot v is going to equal, I'll write it out. You don't have to write it out. -2 times -3 plus 4 times 6 is equal to -6 plus 24 is equal to 18. Yes?
That's subtraction.
So 18. What is the units of this? No, that was a trick question. No, that's a trick question. It's unitless. It's just a scalar. It's like asking what is the units of do. It's just do. No units. All right. Let's have a go at finding u. Yeah, just because the question wants an angle doesn't mean every number we produce is an angle. So what did we get for the magnitude of V?
Root 40.
Root 40, that sounds correct.
So 2 of these unknown.
So then we are going to need to assemble everything using the formula that U dot V is equal to the absolute of U, the absolute of V, cosine of the angle. This implies that theta is equal to arc cosine of UV over UV. So the arc cosine of 18 over 10 root 10. Pop that into our calculator. I got 55.4 degrees. Now the degree symbol comes in. Make sure your calculator is in degrees. We've been using radians all year. So make sure you're switched over to degrees for this. And we should have this as our answer. What did I get the other day? 55.3. Why have I written 4? Okay. Have a go at this question. Shall pause the video for you. Okay, so what we're going to do is I'm going to show you how to do some routines there on the calculator. So first up, if you notice over here next to the 9, you can see the templates button. So click the templates button here. Up pops this. You want to scroll to this bit here in the middle, which will give us a 2x1 vector. Then we're going to take the first vector, u, which is 5 and -3. Scroll across, and then above the variables button, you see the store. Go Control Store. We are going to store this in U, like that. When you press Enter here, the vector is now stored in the variable U, and we can use it like this. So repeat that now and store V. Repeat that now and store V. So press the templates button, pull up the vector, type in our values, 6 and 10, and then Control Store. We want to store this in V. So to get all of the bits and pieces for this, I'm going to have to use this. We need to get U times V. So we'll do it here on the calculator. So if we press Menu, you're going to find a lot of useful tools here under Matrix and Variables. Matrix and Vectors. Now this one, if we scroll down to the Vector Operations, C on mine, it's the dot product that we want. So we get a function for the dot product, and we're going to type in U, comma, V. This will give us the dot product of U times V, which is 0. What does that mean?
The perpendicular.
Okay, so we're in a little trouble here on this one. Now, if you remember that that U dot V is equal to the absolute value of U times the absolute value of V times the cosine of, theta. I don't have a theta. Where's theta? Times the cosine of theta. So how can this statement be equal to 0? There is only one possibility for that, and that is if the angle between them is 0. So in this case, we have 0 on the top. We have 0 on the top. That means that the angle between these two is going to be 90 degrees. We could stop there. I'm going to continue on showing you some routines on your calculator a little bit further. So let's say now we need the magnitude of u. We can do this on the calculator by pressing menu, matrix, and what you want is norms. You want the norm. You want the norm of u. There we go, root 34. Nice. Okay, have fun. What is the magnitude of v? Use your calculator to help you find it.
Root 136.
So menu, vectors, norms, norm. What is it we're putting in? U and v. 2 root 34. So let's multiply these two together. So we want this multiplied by this. It's going to give us 68. So we get 68 here. What is the arc cosine of 0 over 68? Let's try it on our calculator. Make sure your calculator is in degrees. We take the arc cosine of 0 over 68, and we get 90 degrees. Going a little bit long way around through this, but this is a very useful result. If the dot product is 0, you have perpendicular vectors. Perpendicular vectors are very useful in problem solving, and this result is very useful. But some fun routines there on the calculator on how to do dot product, find the magnitude, create new vectors. So let's say we wanted the unit vector for one of those. I'll just do a unit vector example. So we would want 1 over menu norms, norm of u multiplied by u. And this is the unit vector for u. Okay, have a go now at what we're going to do. This part of the course is really important for those of you who haven't seen the sine rule and the cosine rule. If you're in grade 10, you might have skipped this, and this is a prerequisite knowledge for doing the IB next year. So when you come to solving the problems like this, for those of you in grade 10, you need to solve the problems using the law of sine and the law of cosines. You need to practice using these. Oops. Okay, have a go at solving this problem. Okay, so we've got a plane leaving the airport heading 20 degrees south of east at 600 miles per hour. Start by trying to make sense of this problem by drawing a sketch. So I'm going to start off with some compass axes like this. And if you remember, this is north, this is east, this is south, and this is west. So the plane is leaving and it is 20 degrees south of east. So it is coming out and it's going like this. This is going at 600 miles per hour, and our angle in here is 20 degrees. A wind is blowing in the direction of 40 degrees north of east. So 40 degrees north of east is going to give us a smaller vector here, like this. This is, I think it was 25 miles per hour, and we were at an angle of 40 degrees. So there is the problem. What's going to happen is this wind is going to blow the plane out of direction slightly, but it's also going to speed it up a little bit because it's a little bit of a tailwind effect. So what's going to happen is we can transpose that vector over here. It's going to be acting on the plane and creating an effect in this kind of a direction, like this. And it's going to have the same dimensions. And just to help us finish this off, we could sort of place this vector here. It's going to look like this. This is 600. What we need to do is the plane is leaving here and it's going to get pushed as it moves in this direction. So we need to find the length of this green line and the angle of this green line. It's a little bit tricky is the problem.
Can I solve it?
No, I'm going to solve it. Sorry. So this is a parallelogram I've drawn. And if we notice, the angle here in the parallelogram is how much? It's 60 degrees. So here in the parallelogram, how big is the angle here?
120.
120. So from that we can pull off a triangle. We have a triangle with one side equal to 25, one side equal to 600, the angle between them being 120 degrees, and we are after this third side here. We are after this side. So this side here is going to be needed for us to find, so we'll call this one X.
Which I'm confused, wouldn't the angle on that side be 80 because you add the degrees up?
It was 20 and 40, isn't it?
Oh wait, oh okay.
So the angle, if we look here in the diagram, the angle in this corner is going to be less than 60 degrees. The angle here in the triangle is less than 60 degrees. It's the angle in the parallelogram, which is 60. So we can't actually know what this angle here is yet. We can't. Yeah. So the rule is, with a parallelogram, well, just for the sake of the video, with the parallelogram, we have two parallel lines. So these two angles here and here are co-interior angles. And one of the rules that we've seen previously is the sum of co-interior angles is 180 degrees, or in other words, co-interior angles are supplementary. All right, so we've got some information here. This is enough to solve the problem. When it comes to using the sine and cosine rule, notice we have two formulas here for the sine and cosine rule. Always try and use the sine rule first. It's the easiest rule to use. But one of the difficulties with the sine rule is you have to have a side and the angle opposite. You have to know one side and the angle opposite. You can then use that information, which creates a particular ratio that lets you solve all the other bits and pieces of the problem. Now, we only know one angle, but we don't know the side opposite that angle. So if we can't use the sine rule, we turn to the cosine rule. The cosine rule is a formula that we use when the problem involves just one angle and three sides. So the problem will involve one angle and three sides. So if we look to this, we're going to use the cosine rule. We've got three sides in the problem, and we know one angle. So putting all of this information into the cosine rule, just rewrite it here, is c squared equals a squared plus b squared minus 2ab cosine angle c. So we want x squared is equal to 25 squared plus 600 squared minus 2 times 25 times 600 times the cosine of 120. Put this into your calculator and find your value for x now. Have a go at that now. Just have a go for myself. I'm not getting this right. So we should get 613 miles per hour. Now we also need to find the angle. So what we need to do is we actually need to find this angle here. We need to find this angle here to say in what direction it's going. So first off, we can find the angle in the triangle. That is not quite the same thing. So the angle in the triangle is going to be found first. We need to find theta. Now in this particular problem, we now know that this side is equal to 613. So we have an angle and a side opposite, so we can use the sine rule now, which says that the sine of A over A is equal to the sine of B over B.
So,
Yeah.
if it's calculator, you don't really need to do the sine rule. You can just input SOHCAHTOA.
SOHCAHTOA is only going to work with a right angle triangle.
Oh, this is not right.
So let's write the information in. So the sine of the angle that we want, which is theta, over 600 is going to be equal to the sine of 120 over 612.9 ... We're going to put in the exact value for that one. So rearranging that one, we're going to get theta is equal to arc sine of 600 sine 120 over 612.9 ... Put that into our calculator. What angle do we get? we should get 58.0 degrees. So we're still not there yet, because this angle feature is here, whereas we are after this black angle here. How much below that point is it? But all we need to do is take off this 90 degrees here. Sorry, no, we don't. We need to take off the 40. We need to take off the 40. So the angle that we're after, if we subtract 40 from it, it's going to mean that we are going at a speed of, so our conclusion is the ground speed is at 613 miles per hour at, so taking off 40 means it's 18 degrees, at 18 degrees south of east. There is our solution.
Question.
Yes.
Couldn't you just take the two vectors and add them together? What?
Let's have a go at the question again using vectors. So
Wait.
this is our solution using, this is nice one, Zinedine. Spoil all the fun. This is our solution using triangle trigonometry. If you're in grade 10 and you haven't done an IM3 course, solve all the problems using triangle trigonometry, you need to use this approach. If you're in grade 11, you can choose to use a bit of both. Do a little bit of both just for revision. This solution is much more elegant. So in the case of vectors, as I don't know if you caught that, but Zinedine pointed out the solution, we have one vector. So I'm just going to draw up a set of axes. I'm going to use it like it's a unit circle type set of axes, referencing from this as our initial line. So our first vector is going off down here with a length of 600 and an angle of -20. Our second vector is going off in this direction with a length of 25 and an angle of 40. We want the resultant vector, which means we transpose that one over to here and we add the two vectors together and we get the resultant vector in this direction. So if U is equal to, how do we do this? So if U is equal to 600 cosine of -20, sine -20, this is U. V is equal to 25 cosine of 40, sine of 40. And we want U plus V. And this will give us our answer. So let me pull up my calculator. Sorry, let me share that for you guys here in the classroom. All right, so what we want to do is we want to enter in our two vectors. So let's start by doing that one. So get your calculators in your hand, you can follow along with this one. So let's do 600 multiplied by, and then pull your templates button up, and we can put in here the cosine of negative 20 over the sine of negative 20. So in component form, it's going to be this. This is the vector u, the plane's path. So let's repeat that now for the vector. Oh, sorry. Let's grab that and store it in u. We want to store this in u. There we go. So u has changed now from our previous value. It is now the new vector. We'll do the same for v. So 25 times, and then we can put in the cosine of 40 over the sine of 40. Storing that in v. So our answer should be u plus v. There. Lovely. Approximately this is our answer. Now these are component forms. So from this x and y values, we need to get the magnitude and the angle. Now there's a routine for that here on the calculator. If we go to vectors, and we go down to convert to polar form. So if we convert that from rectangular form, which is an x and a y value, into polar form, it will give us the answer here as a polar vector. Now, the polar vector is exactly what we want. We want the length of the green line, which is 613, and we want the angle, which is minus 18. Now, if you remember how we referenced our angles, we referenced the angle from east. So this means 18 degrees south of east. So, sorry?
How do you make it work?
Okay, sorry, was there a question there on that one?
Yeah, how do you get the polar, how do you get into polar?
So for the polar form, what I do is I take the resultant vector, which was u plus v. So u plus v, like that. Then I press menu, vectors, vector operations, number C, and then convert to polar. So menu, was it menu 7C4? Enter. Or control enter.
Is this semester exam just unit 1 to 3?
So whenever it's semester exam, of course.
2 days. Sir, are you like, is it going to be a difficult assessment class or
Okay, so our last question for today, exam style question. 3 minutes for this one. Our last question for today. Okay, so our last question, our exam style question for today. The xy plane, the vector u and v are given here. where A is a constant. If U and V are perpendicular, which of the following equations would be the result? A is a constant, okay. If they are perpendicular, means the dot product is 0, which would be the result. All right, so if the dot product is going to be 0, it's going to be A or B. Let's have a go at the dot product. Oops, what happened there? Let's have a go at the dot product for this one. So U dot V is going to be 3 negative 4 times A2, which is going to be 3A minus 8, and this has to equal 0. So the correct answer is going to be D. Just checking if you're awake. A. All right, that is it for today. Have a go with the classwork activities.